Hello viewers, in this video we'll be looking at these problems, how to determine if a function is increasing or decreasing in a given interval. So we have about 4 questions here, 4 functions, A, B, C, D. So let's start with the first one. So I'll be using about 3 methods. So to answer A, what is A? A is f of x equals to square root of x plus 2, then between -1 to 11. So let me use the first method. The first method is just going to be graphical. So you're going to graph this function. So how do you graph this type of function? You start with what? With the square root of x, because this is a square root function. And with a plus 2 here, so if you start from here, this is but you are going to shift this function 2 units to the left. So it means instead of being at 0, you will just go from -2, right? But you are not even interested from -2. You are interested from where? -1 to 11. So you have just like from here to a point 11. But this is the graph of this function. And it's clearly, this is an increasing function. So let's see the second method. The second method is to use definition. We said f is increasing on what? On interval. So what is our interval now? Our interval -1, 11. When is this true? Is that if you take any arbitrary, let me put it this way. If you take any x1, x2 inside where? -1 and 11. So such that what? If you have x1 is less than x2, implies f of x1 less than f of x2. Okay, you can put this one at the end. For all x1, x2 inside -1 and 11. So if this is always true, then we can say f is what? F is increasing. So if this is true, then we said f is increasing. But so this is for increasing. But the problem with this method is that you have to exhaust all the words. It's difficult to exhaust all the point x1, x2 in your interval. Okay, so but then we said f is what? Decreasing. It means if you take x1 less than x2, it implies that f of x1 is greater than what? F of x2. Also, your x1, x2 must come from the same. You can use open interval, it's fine. Or you use closed interval, or it's just going to be good. You can use closed interval. All right, so if we want to use the definition here, this is a nice function. So here we know that what? We know x1, you can take x1 to be -1, and you can take x2 to be any number in this interval. You can take x2 to be even 3, because you see now -1 and 3, they are in this interval. So you see, what is f of x1? F of x1 is -1. Just put -1 into this function, you will have 1. and f of x2, you put 3 here, you have what? Root of 5. So clearly you see that in this case, f of x1 is less than what? F of x2. Not just that, we know that what? X1 is less than x2, and we also got that f of x1 is less than f of x2, because f of x1 is 1, f of x2 is 5. We know that 1 is less than root of 5. Okay, so this gives us an idea that the function is decreasing, right? Is increasing. But what we are not sure is it going to be increasing in all the interval? So we are not really sure, because for us to be sure, we need to exhaust, we need to take, okay, we need to take, maybe now we can take x2 to be maybe 10, 5. Then we say s2, we can change x1 to maybe 3 and change x2 to be 11, because there are infinitely many numbers here in this interval. So, but this gives us an idea. Sometimes it works, sometimes it does not, because the function could be increasing and decreasing at the same time. I mean, in just in one interval. For example, if you have this, let's say you have something like this. You see, if I call this A and this is what? This is B. So you see, within the interval A and B, you have a function increasing, you have decreasing, you have increasing. So in that case, this method is not really the best. So let's use the third method, which is which we call the derivative, first derivative method. So for first derivative method, it says that what? If you have f prime of x to be greater than 0 for all x in your interval, for example, now you can leave it open interval a, b, then this means that your what? Your f is what? Is increasing. And if the derivative is less than 0 for all x in your open interval a, b, it means f is what? Decreasing. So what you need to do now, for example, this is our function f of x is x plus 2. All you need to do is differentiate this function f prime of x, which will be, remember this you can write as x plus 2 to power half. The derivative is going to be half x plus 2 minus half. So this is just going to be 1 over 2 x plus 2. Okay, now don't forget what is our interval is from -1 to 11. So the first thing you can do is to try to get what the critical point is important first. So let's find the critical point. Critical point, it means where f prime is equals to 0 or f prime does not what? You can say it's undefined, right? So if you look at this now, if you look at this, what do we see? The only the only critical value in this case is going to be what makes this 0, right? F prime of x cannot be 0 because there is no, in the numerator you have only 1. So here f prime of x is undefined. When is it undefined? When you have the content here is equals to 0. So when x plus 2 is equals to 0. Because if x plus 2 is equals to 0, you will have 0 in the denominator. And this means that x is equals to -2. Okay? But now x is equals to -2. This is like our number line. So here, this is the minus 2. Let's put it somewhere here. Put it minus 2. But we're actually interested in which interval? If you look at the interval, we're interested in the interval minus 1 to 11. So if this is minus 2, we know that minus 1 is somewhere here and 11 is somewhere here. So it means we don't even need to bother about what? About from minus 2 to minus 1 because it's outside our range. So all you need to do is to test, so we don't need to bother anything here. So in this situation, all you need to do, you just need to take only one number and test. For example, this, let me do this table very well. I will draw it this way. Here is minus 1 and here is what? 11. So this is going to be, I'll just make it longer. Now, what is our f prime? Remember, our f prime is this one. Our f prime is 1 over 2 root of x. So all I need to do is to take a number here. I'll just take any number between minus 1 and what? And 11. And plug it into your f prime of x. So if you plug it, what do we get? For example, take x to be what? 0. If you take 0, plug it here, what will be our f prime? You see that f prime of x is going to be just 1 over what? 2 root 2. And you can see this is a positive number. So it means that what it is telling you is that between minus 1 and 11, any number you take, actually, the first derivative is going to be what? Is going to be positive. You don't need to test all the numbers. Only one is okay. It will work in this case. So f prime of x is, remember, which one did we test? We test just f of 0. So f of 0 is okay. So it means here you are going to have positive. So let's say this is your f inverse of x. So this tells us that what? Between minus 1 and 11, our f prime is what? Is greater than 0. So it means the f is what? Is increasing. Okay, so let's go to question number 2, or question B. If you look at question B, what is it? It's x cubed plus 1. F of x is equals to x cubed plus 1. But now 0 to what? 16. So the first method is to graph. To graph, how do you graph this? This is, you start from the graph of what? X to power 3, which is something like this. This is the graph of x cubed. Then you just shift it 1 unit up. So it's just going to be something like this. 1 unit up. So this is 1. Yeah. And as you can see, this function is what? This function is increasing everywhere. It's increasing. So graphically, you'll see that this is increasing because as you move from left to right, the function is what? The values of y are increasing. So now the other method is you take what? You take some points. You can take x1 to be what? Maybe 0 if you like. You can take x2 to be 16 if you like. You see that x1 is less than what? X2. This is true in this case. Now what is f of x1? Which is f of x1 is the same thing as f of 0. And if you put 0 here into the function, you will get 1. And f of x2 is equals to what? F of what? 16, which is going to be a very big number. So it's going to be 16 squared plus 1. So we know that what? Definitely f of x1 is what? Less than f of x2. So you started with x1 less than x2, and we finish with what? F of x1 is less than f of x2. So the function is what is increasing. But this method is not, just like I said before, it's not always reliable because you will not be able to exhaust all the values in that interval, right? So let's do the derivative one. For the derivative, the first derivative test, what do? Just take the function. Remember the function is x cubed plus 1. What is the derivative? Is 3x squared. Now, what is the critical point? The critical point will be this when the derivative is 0. And you can see that this will give you x is equals to 0. But what is our interval? We're looking for interval 0, 16. So just draw a line. Now, 0 is a critical point. So it means you only have 0 and you have what? 16. Yeah. So now take any point here between 0 and 16 and substitute it into your derivative. So pick any value here. For example, you can use 2 just to test. So if you put 2 here, remember the what is f prime of x? F prime of x is just 3x squared. So if you put, if you substitute here, put x equals to 2, you're going to have 12, which is positive. So just put plus here. So it means that what we are saying is that what f prime of x is always positive for any x you take, as long as you take x inside what? 0 and what? It doesn't have to be open, just 0 and open. Open is okay. It doesn't have to be closed. Yep. It should be open. Because if you look here, we are using what? You're using open, A, B, not closed. So you see, since we know that f prime of x is greater than 0, and this is true. Remember, what is your f prime of x? Your f prime of x is 3x squared. So whatever is x coming from 0 to 16, you're going to get a positive number. It's not going to be negative. So the function is what is increasing. Then C, what is C? C is, what is that function? Okay, minus x squared plus 4. Minus x squared plus 4. But now you are interval minus 2, 2. Okay, so if you want to graph this one, so let's see method 1 the same way. You have to graph. Look at this function. Start with the graph of what? X squared, right? But because there is a minus here, it means you should reflect the graph across the x-axis. So it becomes something like this. Now, with a plus 4, this is a horizontal vertical translation. So you shift everything up by 4. So you have something like this. So this is 4. Now you need to know where is it going, what is going to be these x values, and these are just the x-intercepts. And if you try to solve this x squared plus 4, put it equals to 0, you'll have x squared is what? Is 4. So x is what? Plus minus 2. So, and these are our that is our interval actually. So now you see this one is nice. This is nice. It's a nice question to look at, but why is it nice? If you try to use the other method, you will have a problem. I mean, the second method. Because if you look at this function, at some point it is increasing, while at some point it is what? Decreasing. So here it is increasing, here it is what? So actually from the graph, you can see that this is 0. So between -2 to 0, right, f is what? Increasing. But between, so let's just leave it open instead of closing them. Then between 0 and what? 2, f is what? Decreasing. So you see the function is increasing and decreasing in which interval? In this interval. So if you try to use the method 2, let's say we try to use method 2. If we try to use method 2, let's say you take x1 to be what? -2. And you take x2 to be, let's say, 2. So we agree that x1 is less than what? X2. Yes. But what is f of x1? F of x1 is going to be, just put f of x1 is going to be f of -2, which is going to be -4 plus 4, which is 0. Then f of what? F of x2 is going to be f of what? 2, which is also going to be what? -4 plus 4 equals to 0. So here you can see that x1 is less than x2, but f of x1 is the same thing as f of x2. So we cannot conclude. We're not sure whether it is increasing or decreasing. So, and another problem is even this one. Now let's see. Let's take x1. Let's assume we take x1 to be what? -2, and we take x2 to be what? To be not 3 but 1. What is f of? We agree that what? X1 is less than what? X2. But what is f of x1? F of x1 is going to be put -2 there. Is going to be 0. But what is f of x2? F of x2 is going to be 1. No, sorry, x2 is 1. So put 1 here. You're going to have -1 plus 4, which is going to be what? Which is going to be 3. So you can see in this case, there is it's not really giving us, in this case is telling us that what the function is what? Is increasing. But this is not really true, because we can see that here from -2 to 0 it's increasing, but from 0 to from 0 to 2 is going to be decreasing. So in this case, this method will not give us a good solution. So preferably use what? The first derivative test, which is now method 3. Okay, so try to get this one clear. We can actually decide from here, even without doing this. You see that what? There is already a problem, because if you take, when we take x1 to be -2 and x2 to be this, x1 is less than x2, but you see that f of x1 is equals to 0. F of x2 is also what? 0. So you cannot conclude using this method. So derivative, what do? You differentiate the function. Remember, what is the function? The function is what? The function is -x² plus 4. So the derivative is going to be -2x only, right? So what is the critical point? The critical point is just this equals to 0, which means that -2x is equals to 0, and this implies x is equals to 0. So what you will do is come to your number line. The critical point should always be on the number line. Now, that is if it is, remember, we have an interval. The interval is -2 and what? And 2. So since the critical point is between -2 and 2, put -2 here and put what? And put 2 here. So you have to check what is the sign here and what is the sign of f prime in this interval. So f prime, don't forget that f prime of x is what? Is -2x. So all you need to do is take any number between -2 and 0. Any number between -2 and 0, for example, -1. If you take -1, you will see that f prime of -1 is going to be 2, which is positive number. So it's telling you that what? Between -2 and 0 is going to be positive. Then between 0 and 2, also you need to take a number. For example, take 1. Then you will see that what is f prime of 1? F prime of 1, put 1 here, is going to be -2, which is negative. So this is telling you that here is negative, while here is what? Positive. Remember, we don't have any business with, we only have business between -2 to 2. Okay? So what does this tell us? As you can see, f prime, this is telling us that f prime of x is what? Is positive if x is between what? -2 and 0, and f prime of x is negative if x is between 0 and 2. So this tells you that your function f is increasing here, and this tells you that the function f is what? Decreasing. So it is increasing on where? -2, so you can even close it. -2 to 0 is fine. And decreasing on where? 0 to 2. You can also close this, but I think let's leave them open better. Though it depends on what your textbook is using, but anyone is fine. Okay, so that's it. Then finally is number 4. What is number 4? Number 4 is this function. I call it number 4. Let's say number D. F of x equals to 1 x minus 1. And here we have x is not equals to 1. So here also, now x is not equals to 1. What does that mean? It means just from -infinity to 1 open union 1 this. So this is the same thing as that. That is the domain of the function. Now this function you can draw if you want to do method 1. Just start with the graph of 1 over x, which is something like this. That's it. This is the graph of 1 over x, but now you have -1, so you mean to shift everything 1 unit to the right. So here you can see the vertical asymptote is at 0, but if you go to the right now, the vertical asymptote will no longer be at 0. The vertical asymptote will be at 1. So it means you're going to have something like this. And also this part, you also need to move it like this. And you can see from the graph, what is your y-intercept? Your y-intercept is when x is equals to 0. If x is equals to 0, you're going to have -1. So this is our y-intercept. So this is the graph. So from this graph, what can we see? We can see that f is what? Is decreasing. Is it decreasing here? Yeah, this is decreasing. It's a decreasing function. But here is decreasing from -infinity to where? To 1. Because this is x equals to 1. And here also is decreasing here. So it's also decreasing here. From where? Okay, so you can see that this is decreasing. Now, also here, not just is decreasing in two places. So this will be union. It's also decreasing from 1 to where? From 1 to infinity, as you can see. 1 to infinity. So that's it. Now, here in this situation, you have an, remember what we had was what was minus the domain is minus infinity to 1 union 1 to infinity is the domain of the function. So for this type, don't even bother to use the second method, but you can use the what? You can use the third method, which is the derivative method of first derivative. So what do? You differentiate. What is the function? This is the function which you can find the derivative. This function, you can write it as x minus 1 to power minus 1. So the derivative now minus 1 will come down. You have x minus 1, the power becomes minus 2. So this is minus x minus 1 square. So this is the derivative here. And from this derivative, you can get what? The critical point. The critical point will be what? The critical point will just be x equals to 1. Because at x equals to 1, the derivative is not defined. So once you have this, all you need to do is just go and draw your number line, put the critical value, the critical point, which is 1. It's very important. So that is it. And if you put 1 here, you don't have, remember, the interval is this union 1 to infinity. So all you need to do is just leave it 1. And here means minus infinity. Here means what? Infinity. So you just need to test the point here. Take any point between minus infinity and 1. For example, between minus infinity and 1, 0 is here. Yes? So just find what is f prime of 0. F prime of 0 is going to be, just put 0 here. You will have what? You will have minus 1 over 1, which is going to be minus 1. You are not interested in the value, you just want to know the sign. You can see it is negative. Minus 1 is less than 0. So what that tells you is that between minus infinity to 1, you have negative. Now also take a number between 1 and infinity. You can take 2. So what do? Find what is f prime of what? 2. It's going to be minus 1, 2 minus 1, yeah? Square. So this is still going to be minus 1. So which is still negative. So here is also negative. So what does that tells you? This means that, remember, the signs I'm putting in this bracket are the signs of f derivative. So it means f prime of x is less than 0. So for any x in what? For any x in minus infinity to 1. And what does this mean? This means that f is what? Decreasing. Is decreasing on which interval? Is decreasing on minus infinity to 1. Here also, you see, it's also negative. So f prime of x is also negative for any x you take from where? 1 to infinity. This also means that f is what? Is also decreasing from where? From 1 to infinity. So you can see in both cases we have decreasing. So you can combine them and say it, hence f is what? Decreasing. Then you can take the union of the two intervals. All right, so I think that is it. So the what is the summary here? If you are using the first derivative method, first of all, find the critical point, then use that critical point on your number line and try to get what is the sign of your f derivative, your derivative of f in those sub intervals. All right, so I hope this is clear.